Okay, this is Algebra 1, Lesson 7.5. We're going to look at rational exponents today. So let's start with our warm-up. Go ahead and quickly do this if you haven't already. So number 1 says the square root of 36. So remember that means what number times itself will equal 36, and that number is 6, because 6 times 6 is 36. And this next one, the fifth root of 0, we want to know what number times itself 5 times is going to equal 0. Well, the only number times itself that equals 0 is 0. So we know that 0 times 0 times 0 times 0 times 0, 5 times, is 0. Okay, for number 3, what number we want to know? It's the cube root of 64. So what number times itself 3 times will equal 64? Well, I would start small. If you tried 2, 2 times 2 is 4, times another 2 is 8, so it can't be that. 3 times 3 is 9, times another 3 is 27, so it's not that. 4 times 4 is 16, and then 16 times another 4 is 64, so the answer is 4. Okay. The next one, the fourth root of 1, the only number times itself 4 times that will get you 1 is 1. The fifth root of 100,000, so what number times itself 5 times will equal 1,000 or 100,000? Well, if you look, 1, 2, 3, 4, 5, there's 5 zeros, so that should be 10, because 10 times itself 5 times will give you 5 zeros after the 1, so that's why it's 10. Okay, in this one, the negative sign is out in front, so we have to put that out in front, and then the cube root of 27, so what number times itself 3 times gives you 27? Well, it's 3, so the answer is negative 3, because 3 times 3 times 3 is 27. Okay, so today we're going to look at evaluating simplifying expressions containing rational exponents, and then you're going to hear the word index, so I'm going to explain what that is right now. So recall that the radical symbol, this one right here, is used to indicate roots. The index is the small number to the left of the radical symbol, and it tells you which root to take. For example, this symbol right here represents a cube root. Since 2 cubed, 2 times 2 times 2 equals 8, the cube root of 8 is 2. So that tells you what you're trying to figure out what number times itself, whatever that many times that's written up here is equal to the number under the radical sign. Another way to write the nth root is by using a fractional exponent. For example, when b is greater than 1, suppose that we have the square root of b is the same thing as b to the k, and we want to know what does that k power mean. Well, I'm going to explain to you how we write a radical sign as a fractional exponent. So here we go. Okay, so the square root of b, they're telling us, is equal to b to some power. We don't know what that power is yet. We're going to solve for it. If I square both sides here, when I square a radical sign, all that does is it takes what's ever underneath, as long as what's out here is the square root. Okay, we don't write a 2, but this is. So if I square this, I will get b underneath, which is b to the first, same thing. And I will get b to the 2k, because this multiplies by that. Okay? Now, because these have the same base right here, I connect on both sides. I can cancel those and get 1 equals 2k. If I divide both sides by 2, I'll get that k is equal to 1/2. So when b is greater than 1, okay, the square root of any number, b, is the same thing as that number to the 1/2 power, okay? When b is 0, whatever that root is just going to be 0, and when b is 1, whatever the root is, it'll just be 1. So a number raised to a power of 1 over n is equal to the nth root of that number. So for example, if I have 3 to the 1/2 power, that's the same thing as the square root of 3. Remember, there's an implied 2 here. We don't really write that. If I have 5 to the 1/4 power, that's the same thing as the 4th root of 5. If I have 2 to the 1/7 power, that's the same thing as the 7th root of 2. So you can write any root as a fractional exponent. So we're going to simplify this expression, okay? So if it's written to the 1/3 power, remember we can rewrite that as the 3rd root of 343. And if you don't know what number times itself 3 times equals 343, well, it's 7. Because 7 times 7 times 7 is 343. Okay, so I can rewrite 32 to the 1/5 power. I can rewrite that as the 5th root of 32 plus the square root of 9. Okay, the 5th root of 32, so what number times itself 5 times will equal 32? It's 2. 2 times 2 times 2 times 2 times 2 equals 32. And the square root of 9 is 3, so we're left with 2 plus 3, which is 5. A fractional exponent can have a numerator other than 1, as in the expression b to the 2/3 power. So some number to another fraction. So this doesn't always have to be a 1. And you can write that exponent as a product in 2 different ways. So here we go. Let me explain this. If I have b to the 2/3 power, that's the same thing as b to the 1/3 times 2 power. So it can have 2. We can split it up. So I could rewrite it like this. And then you can rewrite what is on the inside as the root. So remember, whatever's in the denominator, that's your index, your root. And then I have a square on the outside, okay? You could also rewrite it like this so that I have the, whatever was in the numerator is under the radical. So these are both the same thing, okay? So whatever is in the denominator is your index, always. And whatever is in the numerator is always either outside squared or underneath, or sorry, it's not always squared. Whatever that number is, it goes outside. So those are both correct ways to write it, so whichever is easier. So here's some more examples. If I have 8 to the 2/3 power, I can either write that as the cube root of 8, because that's what's in the denominator, all squared, because that's what's in the numerator. Or I could write it as 8 squared, so that's underneath, and then the cube root of that. So again, this denominator is always your index, okay? And both answers would be the same thing in this case. So we're going to simplify this expression, okay? So here's the 2 ways we can write it. We can either write it as the 4th root of 81 all to the 5th power. So remember, this is always our index. Or I can write it as the 4th root of 81 all to the 5th power. So those are the same thing. I think that this would take a long time to do, 81 to the 5th power. However, I think taking the 4th root of 81, in this case, I would use this one, it's faster. The 4th root of 81 is 3, because 3 times 3 times 3 times 3 equals 81. So we still have 3 on the inside, and we have that to the 5th power. Since you don't have a calculator, you could leave this as 3 to the 5th if you wanted, but if you wanted to multiply it out, this is equal to 243. Okay, for this next one, so we can rewrite this as the 5th root of 32 to the 3rd power, or the 5th root of 32 all to the 3rd power. So remember, this is what's on the out, what you're cubing. This is what's the index. Again, I think 32 times 32 times 32 is too much to do with without a calculator. So I would work on the 5th root of 32 first, which is 2. And then we have a cube on the outside. So 2 cubed, you should be able to do that in your head. You don't need to leave that as 2 cubed is 8. Okay, so now we have a word problem. Given a cube with a surface area of S and the volume V of the cube can be found by using the formula V equals S divided by 6 all to the 3/2 power. So the surface area is S and V is the volume. So they're giving you this formula. You don't have to memorize it. They're already giving it to you. They want to know what is the volume if the surface area is 54. So we're going to plug in 54 into S, and it's all raised to the 3/2 power. Okay? Let's rewrite this how we do with our fractional exponents. Actually, let's take care of this first. If you can simplify what's in the parentheses, do that first. 54 divided by 6 is, 54 divided by 6 is 9. Oops. So 54 divided by 6 is 9. So if you can do that first. That would be a lot easier for you. So 9 to the 3/2 power. We can rewrite this as the cube root of 9 all squared, or all cubed, sorry, the square root of 9. It should be the square root because remember this is what goes in the index, all cubed or we can write it as 9 cubed and then the square root of that. Let's go with this one because it's easier to take the square root of 9 first than cubing 9 and then taking the square root of that. The square root of 9 is 3. So then we have 3 to the third power, which is equal to 3 times 3 is 9 times another 3 is 27. So your answer is 27 meters cubed. Okay. Just remember that the radical sign always indicates a non-negative square root. If you simplify a variable expression that has a radical sign, like the square root of x squared, the answer cannot be negative. X may be, but x itself may be negative. Therefore, if you simplify the square root of x, remember that if we have the same index here and the same index here, those cancel and we just have what's left inside. You have to write it as the absolute value of x to make sure that you get a non-negative answer. So whenever the index and then the power underneath, when they're the same and they're even, you have to make sure that you use the absolute value signs, okay? So pretty much it's for your square. So you have to remember this. Anything that has a square underneath and then the square root, or you'll just see it like this, you have to write that as the absolute value of x. You can't just write x. So if it's even, that's when you have to do that. If you have this, your answer is just x. Those cancel and it's just x. You don't need the absolute value. So if it's an even here and they're the same, that's when you need the absolute values, okay? If n is, so again, if n is even, you must simplify it to the absolute value because you don't know if x is positive or negative. If it's odd and they're the same here, all it is just what's underneath. You don't have to put absolute value signs. Just a helpful hint, if you're told that all the variables are non-negative numbers, so if they tell you in the problem, you don't have to put the absolute value signs in your answers because they're already saying it's all non-negative numbers. So let's simplify all the simplify, and they're telling you all the variables represent non-negative numbers, so you don't need the absolute value sign, okay? All right, I am going to split this up, and we can do this. Because it is a multiplication, I can split it up like this as long as I keep the root the same, and I have to keep it on both of them. So since I have the fourth root of a to the fourth, that becomes a. So this is a multiplication in here. This, if you want to rewrite this as b to the 20 over 4, because this is our numerator, this is our denominator, and then 20 over 4, 20 divided by 4, simplifies to 5. So your answer is a times b to the 5th. Okay, so again, we're going to simplify. Let's do, there's a few ways we could do this. You could rewrite this as a square root. So you could do square root of x to the 6th, y to the 4th, times y. And it's, again, they're telling you it's all negative because this is here and there's a 2 here. Or you could distribute this first if you wanted to. So we could do it this way as well. So x to the 6th times 1/2. 1/2 of 6 is 3. And then 1/2 of 4 is 2. And then this still becomes y. So we have x to the 3rd, y to the 2nd, and then remember it's an implied 1 here. And since these are the same base, we can add those exponents, so we get x to the 3rd, y to the 3rd. If you did it this way, you could split it up, but then you're just gonna, things will get a little messy. So I would, in this case, since it was a simple distribution like that and it canceled out easily, I would distribute first. I think that just makes life easier. So remember, you do have to make sure you combine like exponents. Okay, last example. So we've got a bunch of examples here. Go ahead and try these, make sure you're on the right track, and I'll walk you through them. Okay, so we're going to rewrite this as the 4th root of 16, because remember the denominator becomes the index and the numerator becomes what's inside, or to the first, it doesn't matter. So let me erase those little things because we don't need them. Okay. So the 4th root of 16, what number times itself 4 times equals 16? Well, 1 doesn't equal that, so let's try 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16. So the answer is 2. Okay, I'm going to rewrite these with radical signs. So the square root of 144, I don't have to put the 2 here. If you want to, you can, but it's implied, minus the cube root of 27. Remember, this is what goes in the index. Okay, the square root of 144, you guys, these types of things you should memorize, is 12. And the cube root of 27 is 3, because 3 times 3 times 3 is 27. So 12 minus 3 equals 9. Okay, I'm going to write this down here. So this is the square root of 81 all to the third power, or you could write it as 81 to the third power, or let me get rid of those, squared, or cube root. I think this one is frustrating to do because it's easier to take the square root of 81 first, which is 9, and then you have that cubed. Again, you don't have a calculator, I know, but if you could do that, it would be 729. All right, I'm going to rewrite number 4 over here, so 64 to the 7th sixth. Okay, so we're going to rewrite this as the 6th root of 64, so that's my index because it's my denominator, all to the 7th power, because that's what's in my numerator. Okay, so what number times itself 6 times equals 64? Let's start small. Let's try 2. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, and then, oh wait, I messed it up. How many 2's do I have? 1, 2, 3, 4, 5, 6. Okay, so 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64. So the answer is 2 on the inside to the 7th power. Now, we know that 2 to the 6th power is 64, so to the 7th power, it would just be 64 times another 2, which is equal to 128. So the big thing from this lesson, you guys, is for fractional exponents and then radicals, you have to know that the index becomes your denominator and the number underneath that power or the outside power is your numerator. And that will really help you to solve these rational expressions.